Hey guys, all right, so we're gonna go over solving systems of equations using elimination. Okay, so this is just another method, just like substitution or graphing. This is the method that I prefer because I feel like you can use it on more types of problems, but it's up to you what you prefer. But today you're gonna go over and you're gonna learn how to do these. So there's 4 different ways we can do this. One of the ways is to add, one way is to subtract, and one way involves multiplication and then adding or subtracting. Kind of depends. So to start with, let's just reiterate. So first off, eliminate meaning that we're getting rid of something. So we're trying to get rid of one of our variables. So then we only have one variable, we can solve for it, and then solve for the one that we eliminated. So remember, if we have positive 2 minus positive 2, that gives us 0. Or negative 2 minus negative 2 will give us 0. So with subtracting, both terms have to be the exact same number and the exact same sign. Now when adding, if I have 4 plus negative 4, that gives me 0. And then 2 minus negative 2 will also give me, no, that does not give me 0, sorry. Negative 2 plus 2 gives me 0. Okay, so what we're saying is that here when we're adding, you have to have opposite signs. One's negative, one's positive. Here, again, one positive, one negative when adding to eliminate. When subtracting, they're the exact same number, exact same sign. All right, so when I look at this first problem, this first example, it does look like I could do substitution because x is by itself, but this is another method that we can use. So when looking at this, I noticed that my 2's here, the y's, one's positive, one's negative. So what I can do is I can just simply add these two equations together. So when you add them, we're adding like terms. So x plus 5x gives me 6x. These eliminate, so they're gone. Negative 2 plus 2 is 0. 0 times y is 0. And then negative 19 plus 1 gives me negative 18. And then I go through and I solve this and I get x equals negative 3. Once I know that x equals negative 3, I'm going to take that answer and I can plug it back in anywhere I want. I'm choosing to do the first equation because I feel like that's going to be easiest. So I have negative 3 minus 2y equals negative 19. So all I'm going to do is add 3 to both sides and get negative 16, and then divide by negative 2, and we get y equals 8. So my solution here is negative 3, 8. And again, we write it as a coordinate point because it's not a word problem. The x value goes first and then the y value. Okay, so again, on this one, we added to eliminate. We added to eliminate because of I noticed that the y values here, one was positive, one was negative. They're the same number. All right, so then let's look at the next one, subtract to eliminate. So again, if I look at my y values in this case, they're the exact same, positive 2 and positive 2. So to eliminate that, or to get that down to 0, I can just subtract. So if I subtract these, I'm left with negative 5x equals negative 10. So I'm going to divide each side by negative 5, and I get that x equals 2. Okay, again, 2 minus 2 is going to give me 0, so the y's cancel. So now I need to go back and plug this into any of the equations that I want to plug it into. It really doesn't matter which one you plug it into. Both are the exact same. So I'm just choosing the second equation. So I have negative 5. Instead of x, I write 2, because that's what x equals, plus 2y equals 6. So I'm just going to go through and do the math, the algebra that goes along with this. So I end up with 2y equals 16. So y equals 8. So here my solution is 2, 8. So x was 2, y was 8, 2, 8. Write it as a coordinate point. Okay, so again, add to eliminate when your signs are different. Subtract to eliminate when your signs are the exact same coefficients, all of that. All right, on to multiplying. So now if I look at these, if I look at the x's and then I look at the y's, nothing's the exact same. And so I can't just add or subtract. However, when looking at the y values, I notice that the second y value is 8. Now I could make this, and it's a positive 8, so I could make this a positive 16 to match this negative 16, and then all I'd have to do is add and eliminate. I prefer to always add to eliminate. That's just kind of my preference. So I try to make equations to where I can add them to eliminate. So what I'm going to do is I am actually going to multiply the second equation by 2. And by doing that, all I'm going to do is I'm going to change this y value so that I can use elimination. All right, so I'm going to rewrite the first equation because I'm not doing anything to it. So 5x minus 16y equals negative 2. I didn't touch that one. The second one, I'm going to multiply every single term by 2. So it's like distributive property. So this one's going to be 10x plus 16y equals 56. All right, now these are the equations I'm going to use. So now if I look at it, my y values are now negative 16 and positive 16. So now I can just add to eliminate the y. So these are going to cancel each other out. So I have 15x equals 54. Where did I get 10x? I apologize. I did that wrong. Okay, go back. Sorry. This should be 4x. I apologize. 4x. And then that would give us 9x. I apologize. All right, so again, 2 times 2, if Miss Carol could do her math better, that would be 4x, not 10x. All right, so now we divide both sides by 9, and we get x equals 6. Once I know that x equals 6, I have 3 different options to plug this back in. I can plug it back into the original first one, the original second one, or the one that I multiplied and got. It doesn't matter which equation I plug that back into. So I'm just going to go with this second equation. So I have 2 times 6 plus 8y equals 28. So I have 12 plus 8y equals 28. Subtract 12 from both sides, and I end up with 8y equals 16. Divide by 8, and y equals 2. So again, my solution here is 6, 2. Okay, so again, what I did is I looked and I noticed that my y values in the very beginning, I noticed that the y values are, so right here, I noticed my y values. I could easily eliminate my y by just multiplying this 8 by 2 to get the 16. Okay, so then I did that and I rewrote my equations. I did the math correctly this time and I got 4x, not 10x. So 4x plus 16y equals 56. So I just multiplied everything in this second equation by 2. And then I added the 2 equations, and by adding, I eliminated the y's. So 5x plus 4x equals 9x, negative 2 plus 56 gives me 54, and then solve for x. Once I solve for x, I then am going to go back and I solve for y by plugging the x into any of the equations. It doesn't matter which one. Okay, so that's when we only have to multiply 1 time to eliminate. Now, multiplying twice to eliminate. So these are the type of problems, these are your hardest problems probably that you're going to face when it comes to systems. So substitution doesn't really work, graphing doesn't really work, so then we're going to have to use elimination. But when we look at this, I don't have anything, this is a 7 and this is a 6. I can't multiply one of those numbers and get the other one really easily. And then this one's 7 and this one's 2. So again, I can't take 2 times something to get 7. That would be really easy. I could do decimals, but again, we're going to try to avoid decimals and fractions if we can. So what we're going to do is we're actually going to multiply both equations here. So I look at this and I say, okay, I've got a 7 and a 2. Those are my y's. And then the x's are 7 and 6's. Well, I can already tell that when multiplying by a 7 or a 6 or something like that, I'm going to have really large numbers. So I'm going to choose to do the y's. I'm going to choose to eliminate y. So that's what I'm going to first establish. I'm eliminating y. It doesn't matter. You could eliminate x. So when I eliminate y, what I'm going to do is this. I notice that they're both negative. So what I'm going to do is I like to add to eliminate. And in order to add to eliminate, you have to have one positive and one negative. So I'm going to multiply the top equation by a positive 2. So basically I chose this right here, and I'm going to multiply the top equation by that number. And then the bottom equation, I'm going to multiply by the number that's in front of the y in the first equation. So this is negative 7. Notice that I made this one negative and the first one positive. So by making them opposite signs, I'm going to make my y values opposite signs so I can add to eliminate. Okay? So again, the second one, this is a negative 7 here because I want to make this a positive y so that when I have to eliminate, I can add to eliminate. Okay, I like adding to eliminate much better than subtracting, because with subtracting, sometimes you have some negatives and you're subtracting, and that's where you can make more mistakes. Okay, so I'm going to rewrite both of these equations. Okay, so the first equation here, so I'm going to take 2 times negative 7, 2 times negative 7, and then 2 times 14. So I'm going to end up with negative 14x minus 14y equals 28. Just multiplied everything by 2. Okay. All right. So then I'm going to do the second one. I'm going to multiply everything by negative 7. So negative 7 times negative 6 is a positive 42x. And then negative 7 times negative 2 is a positive 14y. And negative 7 times negative 28 is a positive 196. Okay. So again, all I did was multiply, right? I multiplied. And now when I look at my equation, I notice... Here, let's get this back to yellow. I notice that my y values here are the same with opposite symbols. So now I can just simply add my two equations and eliminate my y. So when I do that, I end up with 28x, the y's eliminate, equals 224. Divide both sides by 28, so just your simple algebra, and x equals 8. So now that I know that x equals 8, I have 4 different options that I can plug this back into. I can plug it back into the first equation, the second equation, the third equation, or the fourth equation. All 4 of those equations would work. Okay, so I'm just going to choose to put it into, I don't know, let's do the first equation. So I'm going to plug it back into the first equation. So I have negative 7 times 8 minus 7y equals 14. So I get negative 56 minus 7y equals 14. So again, I'm just going through and I'm going to add 56 to both sides. So I get negative 7y equals 70. And then divide each side by negative 7 and y equals negative 10. So then my solution is 8, negative 10. Now, this looks really complicated and it looks really intimidating, but it's really not. So basically all I did was I decided I was going to eliminate the y values. So I'm going to eliminate the y coordinate, or I'm sorry, the y variable. So to do that, I multiply the top equation by what the second variable, the coefficient to y was. And then I multiply the second equation by what the first coefficient was to y. And again, I made these opposite signs because they are originally both the same sign. So by making them opposite signs, once I multiply, then I have opposite sides down here. And I like opposite signs because I like to add to eliminate. Now, you could have multiplied the top by 2, the bottom by 7, and then subtracted, and you would have gotten the exact same thing. That is completely up to you. Okay? All right, guys, do me a favor, just so I know that you actually went through and listened to this whole video. If you could, on the bottom right-hand corner of your paper, just draw a star. Bottom right-hand corner, draw a star. Okay? All right, so I want you to go ahead and flip over to the back, start working on some of these problems. If you have questions, please come and ask. Thanks, guys.